Okay, so today we're doing 9.4. We're starting 9.4, which is going to be vectors in 3D. And today we're just going to focus on performing operations on the 3D vectors. So vectors in space are going to have a direction that is in three-dimensional space, which you can see in this figure below. Okay, so if this was our vector, you still have your horizontal and your vertical components, but they are in 3D. Okay, good news is we won't have to draw them. So the 9.3, in 9.3 we were graphing the points in 3D form. We are not going to graph the vectors in 3D form. The properties that are going to hold for regular vectors in the plane, so in the 2D, in the 2 dimensions, are going to hold for vectors in space as well, which is why you're going to be able to do pretty much this whole worksheet even without me, because it's going to be the same. You're just going to have one more component. So just remember that the vector has many different representations. It all depends on its initial point. Whenever you have a vector in space with the initial point at the origin, you can describe it as an ordered triple. So these would be your 3 components, or you could do it with I, J, and K. Notice too that, again, they call this component form. So I'll either say component or vector form if we're writing it with our arrow brackets here. If I want it in terms of I and J, I will say component form with terms of I and J. And you guys already did part A, so find the components of a vector. All you have to do is subtract x2 minus x1. So 5 minus 8 was what? Because you guys did this part, right? So do this with me. 5 minus 8 is negative 3. 3 minus 6, negative 3. 0 minus 7, negative 7. Okay, so then this is going to be your components of the vector with those 2 points. Negative 3, negative 3, negative 7. How'd we do? Pretty good? Okay, so the next one, I'm going to show you how to rationalize your way through this. But then we're going to see a pattern emerge that's going to be really quick and easy for you to do. So if you're given this a vector and this is the initial point, we're trying to find the terminal point. Well, if it's an initial point, we can think of that as x1, y1, z1. And based on the equation above, in order to find those, what we do is we take the initial point and subtract what we do is take the terminal point and subtract the initial point from that. So if we wanted to find our first component, we would do x2 minus x1, and for this one, for x, we would end up getting 3. Is that correct? For the x's, right? With the y's, we would have y2 minus y1, that would be 0. And then for the x's, or the z's, z2 minus z1 would equal negative 4. Okay, so those are our components. Well, if this is our initial point, what we could do is we could plug these values in for x1, y1, and z1. So if we have minus negative 3, it's really going to be plus a positive 3. We have y2 minus negative 4, which is really going to be plus 4. And minus 8, which would equal negative 4. So if I wanted to find x2, y2, z2, all I would have to do is solve these for x2, y2, and z2. So to solve this one, I would subtract 3 from both sides. So what would x2 be? 0. What would y2 be? Negative 4, and z2 would be 4. Okay, so then my point would be 0, negative 4, 4. Now, can you guys see a pattern at all? A quick way to do it? Yeah, Colin? Add what?
Add the 1 and 2.
Okay, so yeah, add the components together, right? So if you add x1 to the component from the final vector, negative 3 plus 3 is going to be 0. Negative 4 plus 0 is going to be negative 4. And 8 plus negative 4 is going to be 4. Okay, so that is our terminal point. And you're welcome to add those. I just want you to know where it comes from. Okay, so it comes from this setup where we're just moving our values to the other side. So we're adding those two together. All right, so the next thing we're going to talk about is the magnitude of the vector in 3 dimensions, which you'll see it looks just like the equation for the magnitude in 2 dimensions, but we do have that extra component. So it is going to be a sub 1 squared plus a sub 2 squared plus a sub 3 squared, and we're taking the square root to find the magnitude. Okay, so for example 2, we're going to find the magnitude of the vector 3, -4, 12, and it says give an exact answer. Okay, so if you're given an exact answer, does that mean we're going to have a decimal, or are we going to have a radical if given the choice? No, radical. Which one is it? Radical. If it's exact, right? If it's exact, it'll be the radical. Because if it's a decimal that you round, then that wouldn't be exact. Okay? So you guys are going to give an exact answer for this one. It actually should work out so that it's a perfect square. How many of you have already done this? Okay, so the magnitude of your vector, you should have 3 squared plus -4 squared plus 12 squared. Okay, so 3 squared is 9, -4 squared is 16, 12 squared is 144. You're going to add those together to get 169. Square root of 169 is 13, so that is an exact answer. Now, if this wasn't a perfect square, what you'd want to do is find the perfect squares inside the radical and simplify and keep your answer in terms of a radical. Okay, what questions do you guys have for me? Any of the first page? Good, ready to go to the next one? Okay. Okay, so the algebraic operations on vectors in 3 dimensions, we can see these are exactly the same as the 2 dimensions. When we're adding them together, we're just adding the same components together, okay, in each vector. And then if we're multiplying by a scalar, we are just going to multiply every component by that scalar value. So for example 3, I'm going to give you some time to do that. So you're going to add u and v together. You're going to subtract u minus v, and then you're going to do 2u minus 4v. And if we're adding those together, we'll do -3 plus 4 to get -1. Okay, 0 plus 1 is going to be 1. 2 minus 2 is going to be 0. And then for u minus v, I have -3 minus 4, which is -7. 0 minus 1, which is -1. 2 minus -2, which is going to turn into +2, which would be 4. Okay, now the 2u and the 4v, what I do first is I multiply by the scalar. So if I multiply all of my units in u by 2, I'll have -6, 0, and 4. And for 4v, 4 times 4 will be 16, 4 times 1 will be 4, 4 times -2 will be -8, and then I can simply subtract. So -6 minus 16 will give me -22. 0 minus 4 will be -4. 4 minus -8 is usually going to be +8, which will be 12. Okay, what questions do you guys have for me in example 3? Yes, Sydney?
I don't really get how you got -22
Okay, so do you understand the 2u and the 4v part? Okay, so then to find these, we're just subtracting. So if you do -6 and then subtract 16 from that, okay. Yeah, if they're both negative, it's like you're adding them together, keeping the negative. Okay, good. Any other questions for me? All right, let's do the dot product next. So if you guys remember the dot product is going to be the sum of the products of the components. So you're going to multiply your components together, and then you are adding those components. So for example 4, we're going to find the given dot product. So I will give you guys a minute to do those if you haven't tried them already. I think you can borrow that one. Just put it. Okay, do you guys need more time for part A? Okay, so to find the dot product, what I do is I multiply these together and I write that part down. So -2 times -4 is 8. -3 times -4 is 12. And 7 times 4 is 28. So 8 plus 12 is 20. 20 plus 28 will be 48. Okay, now for B. I have this component I, and I have a -1, but there's no I here. So what do we think our value is for I if there's none?
0.
Yeah, it'll be 0. Okay, so this is 0 times -1, which will be 0. And then 2 times 2, which is 4. And then 7 times 3, which is 21. So when you don't have the same number of components, that can mess people up. You just have to make sure you pay attention to the letters. Okay, so J is going to be multiplied by J, the K by the K. And for that one, you should have 25 as your dot product. Okay, questions for me on example 4? Okay. All right, then the next thing we're going to talk about is the angle between the two vectors in space. So this formula is also going to be familiar. It's the cosine of theta equals the dot product divided by the magnitude, the product of the magnitudes of your two vectors. And then I mentioned this earlier. If U and V are perpendicular, then their dot product is going to be 0. Do you guys remember I told you that other word for it? Orthogonal. Okay, so if it says, are these two vectors orthogonal, that just means perpendicular. And we also talked about why that happens. So if the dot product is 0, right, if I had the cosine of theta equals 0 over the magnitudes, 0 divided by anything is going to be what? 0. Well, when is the cosine going to be 0? At 90 degrees. So because theta would be 90 degrees, that means that they're going to be perpendicular or orthogonal. So for example 5, it says determine whether or not the vectors are perpendicular. So when we're given these vectors, what operation are we going to do for these? What are we going to find?
Dot product.
The dot product. Okay, so let's find the dot product of those two vectors. Okay, so the dot product of U and V. So we're going to do 3 times 3, which is 9. Okay, and then -1 times 6, which is -6. 2 times -3, which is -6. So 9 minus 12 would be -3. Okay, now -3, are these going to be perpendicular? No, because -3 is not equal to 0. Okay, so because -3 does not equal 0, they are not perpendicular. Okay, and if it does equal 0, then yes, they would be. Okay, questions for me on example 5? Okay, so for example 6, it says find the angle expressed in degrees between U and V. If u is 4, 0, 2, and vector v is 2, negative 1, 0. So the first thing I'm going to do is find the dot product between u and v. Actually, I'm going to give you guys some time to do that. If you guys are done, feel free to look up your homework or update your homework. Okay, so did we already find the dot product? Megan, what'd you get? Okay, good. Your dot product is going to be 8. Jesse, did you get the magnitude for u? Yep, okay, good. So the magnitude of u is the square root of 20. Olivia, what's the magnitude for v? Okay, good. So when you're setting this up, you don't have to simplify. I did just because it's going to be easier to plug into your calculator. So when you have 8 over root 20 times 5, I noticed right away that 20 times 5 is what? 100. And what's the square root of 100? 10. So then when I'm plugging this into my calculator, all I have to do is the cosine inverse of 4/5 instead of dealing with all the square roots. Okay, but again, you're going to get the same answer either way. You don't have to simplify that. And when you do the cosine inverse, you're going to get 36.87 degrees or approximately 37 degrees. This one doesn't say what to round to, so whatever you rounded to is fine as long as you rounded correctly for that. And I did round it to the nearest degree because I knew in 2 dimensions that's what the directions said. Remember that when you're trying to find theta, you have to use the inverse. Okay, because you always use the inverse whenever you're finding what?
Angle measure.
Yep, good, an angle measure. Okay. All right, and I'll put the homework on the board and let you guys get started on that.